Hello and welcome to another video. Today we're going to be solving the October-November 2024 paper 4.2. This is for the Cambridge A-level computer science. This is 2-hour paper. So hopefully you will be going ahead and downloading the source file from the link in the description. Alright, so go ahead and let's get started. So first of all, once you download the source file, since these are zip files, I'm going to go ahead and extract them to my desktop right here. I am going to be deleting these files out. So in the source files area, what I'm going to be doing is opening Visual Studio Code. Let's just cancel this out. Yeah, save this. I'll open folder. I'm going to go to, sorry, I'm going to be going to my desktop. Where's my desktop? I'll just click this and select this folder. Okay. So from here, we're going to be creating a new file, which is going to be question1_n24.py. Okay. So with this being said, let's get started. I'm just going to zoom in slightly so that it's a little bit easier to view. All right. So looking at the question, a computer program game is designed for users to select characters. Each character can take part in a group of events. Each group has 5 events, and there are 4 types of events. Okay, there are 4 types. We've got jump, swim, run, and drive. The program is written using object. So the first question is a object-oriented programming. We've got event items, meaning the class. We've got its constructors, which will have the event name, type, difficulty, as I can see over here. We're going to have 3 get methods, which is going to be getting the name. I'm assuming it's going to be event name, event type, and the event difficulty. Okay. So we first need to go ahead and write code for the program and for the constructors. All right. So we have class. Let's go back. I forgot the name. Event item. So def underscore init. We're going to be having self event name, event type, if I'm not wrong. Like we've got event type, right? Event name, just type. Okay, just name it type, type parameter, and we also have difficulty parameter. Then we put some private attributes, meaning event name is going to be event name p. Self, we're going to be having type is going to be type parameter, and self difficulty is going to be difficulty parameter. All right, so next we are going to be going ahead and constructing methods for get name, get difficulty, get event type. Okay, so def get name, this is obviously going to be a private function, so we're going to have get name. This is going to be returning self dot event name def get difficulty. This is going to be self, obviously. We are going to be returning. Now we are using self because these are all private. So we are we're forcing encapsulation. And finally, we've got def for get. We have get event type. I'm trying to keep the names as they've given it in the question paper. Since Cambridge, I don't think follows the Pascal naming convention, so yep. Okay, so we've got. I'm gonna save it. Oops, why isn't it saving? Oh, okay. I'm just gonna be going ahead and adding the Chrome window to my second desktop. It's a little bit easier for me. Okay, the array group stores 5 objects for the event. So the group local. So we're going to be having a group that's going to be a local array. So we're going to be having group local to the main program. So we define a array in Python. And then we're going to be having one group has the following events. Okay, so event name, type, difficulty. All right, so what we're going to do is we're going to do group append, and then we are group append, and in the append area we're going to be doing event item. So the first thing is bridge. The event type is a jump, and then we have the event difficulty as 3. So we have 1, 2, 3, 4, 5. So one more. So in this case, the name is going to be water wade, swim, and this is going to be 4. In this case, the name is going to be 100-mile run. This is going to be run, and it's going to be 5 in this case. So we're going to be putting 5. Gridlock. This is going to be drive, and we are going to be having 2 in this case. Bridge, so this is going to be walk on wall. This is going to be the, this is also jump. Okay, so you've got jumps, 2 jumps over here. Jump, and this is going to be a 4. Great. So we've got the 5 events set up. So now we have the class character stores data about the characters in the game. Each character has skill level for each type of event. The skill level is an integer between 1 and 5 inclusive. The skill level 1 is lowest and the skill level 5 is being the highest skill level. So we've got the character name, jump, swim, run, drive. So this is the values for each character. We got a construct for all of them, and also 2 get methods, get name, and this is not a get method, it's a calculus. So this is probably a takes. Okay, this is going to be a function. We have get name over here. Okay, so we're going to first work with the constructor. So same thing, we're going to need another class name character. So we've got 2 classes in this question. Once again, in init, in the self, we're going to be going for character name parameter. We're going to go for the jump parameter. We're going to be going for the swim parameter. We're going to be going for the run parameter, and finally the drive parameter. Next, we do the self underscore character name is equal to character name p. Self underscore we got jump is going to be jump p. Self underscore we got, I can't see anything because of this crap. Okay, we got swim is going to be swim p. Self dot underscore, if I'm not, it's going to be run. I'm trying to maintain the order, so it's going to be do for run p. And finally, we've got self underscore drive. This is going to be drive p. All right. Looking good in this case. We are also to do its constructors, and we're also to do the get method. So we're going to do def get name. I think that's get name, right? We want to return self dot character name. Okay, so we're done with this part of the question. The next one is to calculate the method. Okay, the method calculates scores in the character class, calculates and returns a percentage chance of a character completing an event. When a character's skill level is greater than or equal to the difficulty, I want to check if I'm still recording. Yes, I am. Okay, when the character skill level is greater than or equal to the difficulty of that event, the percentage chance of completing the event is 100%. So if it's greater than or equal to, okay, to the difficulty of the event, the character completed. When the character skill level is less than the difficulty of the event, the character skill level is subtracted from the difficulty of that event. The difference is used to identify. Okay, so you first need to go ahead and use calculate score. Okay, fine. Calculate score, take the type of event and the difficulty. Okay, calculate the percentage chance and then return that percentage chance. Okay. If the character's skill level of 3 in type of event, the event has a difficulty of 5, you're going to do 5 minus 3, that's going to be 2. and then since it's 2, we're going to be taking 60% of a win rate. All right, great. So first, what we need to do is we need to take the input of the type of event. Once we take the input for the type of event, what we can do after we take the input for the type of event, we have to go ahead and first match which type of event this is. After we match that, we finally can go ahead and calculate it specifically. Like we can bring the data of that particular event from event items. I'm assuming we have to use event items in this case because otherwise I don't think we would have made the group character. Sorry, the group array. So let's go ahead and first work with this calculate score. Def calculate. All right. So we got self, and we're going to be taking event type, and we're going to be taking event difficulty. All right. So first we determine what type of event this is. So if event type is equal to jump, right? If it's equal to jump, because these are all in small letters. Okay, the question hasn't mentioned us that if event type, like the input is going to be taken in capital letters or small letters. Oh, okay, interesting. So as you can see, the following inputs over here are in capitals. So what I want to do is I want to go ahead and take event type and do a dot lower, pass it through a dot lower built-in get method. So what I'm going to be doing is calling this win chance. The chance of winning is going to be self jump. Else if event type dot lower, if it's going to be equal to what we can say is what's the skill? Oh, why am I seeing this? Okay, so we gotta do with swim. Sorry. Then we do win chance equal to self underscore swim. Else if event type dot lower, if the event type is equal to run, what we do is we change win chance to self run. Else, since we don't need to do any exception handling for this code, I'm just going to go ahead and assign win chance to self dot drive. All right, since we don't need to do any error checking. So this part of the code is for setting for which event, right? So we want to go ahead and set for this event. Now what we do is we want to go ahead and do the calculation of success, or winning the event actually. In this case, I'm gonna remove the extra spaces. All right, so from here, what we want to do, if event difficulty, oh no, okay, if you want to do is if win chance, we want to see first if it's greater than or equal to event difficulty, we return 100 because there's a 100% chance of winning. Else if win chance, okay, what we do is we first then find out else, or what we could do, okay, I think this is fine. I'm just going to call it difference, and then what we want to do is we want to go ahead and take event difficulty, since it's going to be less than obviously, and subtract it from win chance, if I'm not wrong, yeah. And then we do another nested loop in this case. Okay, that's going to be okay. Yeah, we ultimately had to do a nested loop, in this case, to make it a little bit efficient. What we could do is just a less than. All right. Then we calculate difference to be event difficulty minus win chance. Oh, we had to do a nested loop either ways, okay. I mean nested conditional statement. All right, that's probably not going to be an issue. Let's go ahead and continue. If difference is equal to, since these are specified values for us, what we do is we return 80. Else if difference is equal to 2, I think we do a 60. Oops, sorry. Return 60. Then we do else if difference is equal to 3, return 40. Else if difference, if it's equal to 4, we return 20. And finally, we just do an else statement. That means everything's working good. We return 100. Okay, so that's a lot of lines, to be honest. All right, so we first determine which event we're talking about. Then we check that if it's less than, because if it's greater than or equal to, it's going to be returning a 100. If win chance, okay. So with this, if it's only enter, oh, okay. So this else statement has to be outside, and then the return is also going to be coming outside. Okay, if none of them, like if it's less than, it's definitely going to be entering this. Else, it'll just return 100. Okay, there we go. So looks like we're good. 1, 2, 3, and then we just did the else statement here. No exception handling, no check cases. So we're good over here, hopefully. Now we're going to be 2 characters attempting. One character is named Tars. Its skill level is this. The other is Jenny. Each character object is stored in a variable. Amend the main program to create an instance of a character object for Tars and Zenny. Or Jenny, actually. All right. So let's go ahead and create an object for both. So I'm going to just name them Tars and Jenny respectively. We're going to be doing a character. Inside the character, we're going to be putting the name. So that's going to be Tars. Tars. We're going to be putting the jump to 5. We're going to be putting the swim to 3. Run to 5. And drive to 1. If I'm not wrong, that was the order of the data. Okay. Same. I'm going to name it Jenny, and then we're going to put character Jenny. And then we have values like 2, 2, 3, 4. Right? 2, 2, 3, 4. Great. With that being said, amend the main program, declare the character, for Char. Okay, both characters, Tars and Jenny, take part in the event in the group you create in part 1b. Okay, so I created a group that was the array. These steps are repeated in the 5 events. The percentage chance of each character completing the event is calculated and compared. The character with the highest percentage chance of completing the event gets a 1 point. Okay, they get 1 point. The character name is output together with the message telling the 1. If both characters same percentage, scores do not change. Okay, and the message is like the event was a draw. The total score has to be calculated. Okay, the name of the character with the highest score outputting high score is output stating that they have won and the number of points they have. Okay, if both characters have the same number of points, a message is output telling them that the group is a draw. All right, so amend the main program to calculate the score for each event. Output the character output most points. The group is a draw. Okay, so we first need to create 2 variables. First, I'm going to call it score underscore Tars. Let's put it as 0. Same score Jenny, that's also 0. Now let's do a for x in, or we could just do for, okay. So for x in group, okay, so that's the number of elements in group. The name was group, right? Yeah, it was group. Okay, so the first thing is we go ahead and find the result for Tars and for Jenny in this case. So what we want to go ahead and do is, that's the score variable. So I'm going to call it percentage Tars. And then what we want to do is we want to go ahead and take Tars, all right. Then we want to go ahead and call calculate score, all right. And in calculate score, we want to go ahead and take the type of the event from group in order to calculate. So what we want to do is we want to go ahead and call group x dot get event type, right? Or was it get event type? Okay, get, sorry, event type. Okay, I'm just going to copy this because I might need it again. Oops, sorry. Percentage Jenny, I'm going to call it percentage Jenny. Then we're going to do Jenny dot calculate score, and we're going to do the exact same thing. So we have this. So if we do that, if percentage Jenny is equal to percentage Tars, then what we do is we print draw. Else if percentage Tars is greater than percentage Jenny, what we do is we increment score Tars by 1 and print Tars won this event. And finally, if that's not the case, then obviously Jenny has won. We're going to increment Jenny's point, print Jenny has won the event. All right. With that being said, I think we are done in this case. For X in group, that's for the 5 elements. Now what we want to go ahead and do is we want to compare who has the higher score. So if score Tars is greater than score Jenny, print Tars has won this group. And obviously if that's not the case, we just want to go ahead and do is print Jenny has won this group. Okay. Now we have to just go ahead and test our program. Let's see if anything even works. Oh, I'm really sorry. I think I was executing my C++ area. Oh. Why is it in code? List indices must be in, oh, okay. So X in group, I get it. So for X in range 5, I'm going to try to run this. Not type error. Okay, listen is not event item. Okay. Tars calculate score group. Isn't it in an integer right now? Let's have a look. Okay, so you've got Tars calculate score X. We've got the event type right here. Missing one position. Event difficulty. Oh, okay. I was like confused. So it's we had two. Oh my god. So we have to also do group crap. Get. I think it was get difficulty. Let's have a look. Yes, it's going to be get difficulty. So we want to do get difficulty, and just want to go ahead and just copy this and paste it. Let's give it a try. Oh, it's all run Python file. There you go. There we go. Okay, so we have a appropriate output. All right, so let's go ahead and start question number 2. So question 2 underscore n24.py. All right. So let's start with question 2. All right, so let's go ahead and start off with question 2 now. All right, so question 2 says it's a linear queue data structure is designed using a record data structure. The record structure queue has the following fields. Okay, queue array, head pointer, tail pointer. Write program code to declare record structure queue in these fields. If a programming language does not support record structures, a class can be declared instead. Okay, so we've got another class question. It's interesting. So the class is going to be queue in this case. We're going to have the array, head pointer, and tail pointer. Okay, so it stores the index of the first data. It stores the index of the next free location in queue array. Okay, interesting. So what we're going to be doing is, let's go to Visual Studio Code, and we're going to be doing class queue. In this case, we're going to be having a head pointer. Another comma. Now in this, we're going to be installing queue. We're going to make these public. Okay, so we have 0 for x in range of 100 integers. Self dot. I'll leave again. These will be public. Like, we're not forcing encapsulation because this is going to be a little bit easier, make our job a little bit easier when we try to code. Since this is not a object-oriented programming question, we don't need to go ahead and encapsulate the attributes inside the class. It's totally fine. So we've created our record structure queue. The main program creates a new queue with the identifier the queue. The head pointer is initialized to -1. The tail pointer is initialized to 0. Each element in the array is initialized with -1. Each element in the array is initialized with -1. Okay. So the main program with the record identifier the queue. Okay. So the queue. Okay, the queue is going to be a queue with the head pointer initialized to -1 and the tail pointer initialized to 0. And if you want each element to be -1, just put -1 there. That's it. Right? That's going to be it for the main program. Function enqueue. Okay, they've given us an enqueue function right here. But let's read through it since it has some incomplete statements. So enqueue is going to be by, okay, so we've got by ref, so it means we need to pass it as a global in Python because Python doesn't allow by ref or by val passings, unlike Visual Basic. The data, okay, that's going to be the data to be entered, and returns an integer. Okay, fine. If a queue, so this is going to be the queue that's entering over here, head pointer is -1, that means there's no data in it. So in the tail pointer, we insert the data since tail pointer is already 0 and increment head pointer to 0, and tail pointer is incremented by 1 and returns 1 to show that the enqueue was successful. Else, if tail pointer is greater than the length of the array in this case, or it could be 99 since it's starting with 0, so it's going to be 99. Then it returns -1. Else, aq tail pointer the data. So it inserts the data since like probably there was some data over there. Tail pointer should be incremented since we're inserting the data, and then we return 1 in this case. So let's go ahead and try to do this. So def enqueue and the data is going to be the parameter. Now in your actual exam, AQ is by ref. What Cambridge wants you to do is just mention it in the comments at least. Then you could do just global the Q. There we go. So now from here, what we're going to be doing is we're going to be starting the if statement that if the Q dot head pointer is equivalent to -1, what we do is we do the Q dot Q array the Q tail pointer. We insert the data, so that's going to be the. Then we change the head pointer to 0, 0. So it's going to be Q array. That's going to be head pointer is now set to 0, and the tail pointer is incremented. So the Q tail pointer is plus equal to 1. Else if the Q dot tail pointer is greater than 99, in this case, we want to go ahead and return -1. Oh, I forgot the statement that it also returns a 1. And finally, we can put this in an else statement that else the Q dot Q array, the Q dot in the tail pointer, we insert the data. We go ahead and increment the tail pointer, so this the Q tail pointer again plus equal to 1. We return 1, and that's it. All right, so we're done with the enqueue function. They've given us the code for it, so it's like very easy at this point. We do have an error I see somewhere. Oh, we forgot to put this. Oops, sorry. So we are done with this part of the code, the program. All right. Let's take a look at the next part. The function return all data accesses the queue. It concatenates all the integer values that have been inserted into the queue's array, starting from the value stored at the head pointer with a space between each integer value. The string concatenated values is returned. None of the integer values are removed from the queue. Write program code. Okay, so we just kind of return what's in the queue technically. Write program code for return all data. So def return all data. In this case, it's going to be global the queue, just to mention. Or you could even ignore the global statement when we're doing this, because here we're not modifying the queue, we're just accessing data from the queue. So you can ignore the global part, okay? Because that's like, you're not universally changing the queue in this case, so it's okay. But you're just going to put it there just for the sake of putting it. Then we're going to concatenate all the integers. So we need to have a integer for the queue. So what we can call it is the return string, all right? And then we put it as a blank quote. Or let's put double quotes here. Okay, now what we want to do is for x in range, the q dot head pointer till the. So from the head pointer till the tail pointer, what we want to do is we want to return the number of values. It concatenates. Okay. So what we want to do is return string equals return string plus the q. The q has integer data, so what we want to do is do the str function over here, and we want to do is the q x dot q. I think it's q array, right? Like q array. The q. Oh, okay. Sorry. Not like that. So it's going to be the q dot q array x. Okay. So what I'm going to do is we're going to return the data in the form of a string, and this continues. And after the loop has ended, we want to go ahead and do return string. It should work. Hopefully it's going to work. We're not going to run into an issue over here. Write program code. Okay, the main program asks the user to go ahead and enter 10 integer values with 0 or greater. It reads each input repeatedly until a valid number. Okay, so we have to do a validation check. All 10 valid inputs are added to the queue using enqueue. And if it's -1, that means the queue is full, so we're going to be returning an appropriate message. Otherwise, we're going to be going ahead and returning, kind of the data has been added to the queue. The function return all data is called once all 10 integers have been entered, and the return value from the function is called, function call is the output. Okay, fine. Amend the main program to perform these actions. Okay. So the user will be entering 10 integers. So we're going to do another x in range 10. So we're going to be doing while true. We're going to do data to add is going to be an integer, obviously, from the user. We're going to be taking an input, enter a number not number 0. If data to add is greater than 0, values 0, okay, values of 0 or greater, so it's greater or equal to 0, then we just go ahead and break out of this. If we do the break function, will it, oh, it's going to be going ahead and breaking out of everything. Okay, we can't use this. So what we need to do is kind of copy this, while data to add is going to be less than 0. What we want to do is we want to do the same thing. Alright, so then it's going to break out. Okay, so we are done with the validation check. Now what we want to do is we want to do the enqueue. So success is equal to enqueue, and we're just going to call the data to add. Right? Once we call data to add, if success is equal to -1, what we want to print is the queue is full, else the enqueue was successful. So what we just do is we do else print enqueue, my English, come on man, and the enqueue was successful. Alright, so I think that should be it, and then we were to use return all data. So what we're going to do is I'm just going to go print return all data. Let's try running the Python file. Enter the number greater than 0, so we're going to be starting off with 10. -9, it doesn't work. Oh, not -9, it was -1. Crap. So what we're going to do is 10, 9, -1. So that's for input again. So 8, 7, 6, 5, 4, 3, 2, 1. Okay, the output is a bit weird. Something went wrong. With a okay, we have to put a space in between. So what we have to kind of do is we're gonna go back to this and just add a space. Now it should work. So you got 10, 9, -1 shouldn't work, and then it's an 8, 7, 6, 5, 4, 3, 2, 1. There we go. So it concatenates and returns the string. Okay, so that should be the output for this part. Okay, let's look at the bottom. The main program, okay, we just did it. Okay, now we have dequeue. Okay, we've got to work with the dequeue part. Okay, the function dequeue accesses the Q, the function returns -1 if the queue is empty. If the queue is not empty, the function returns the next item in the queue and updates the relevant pointers. The data is not replaced or deleted from the queue. Okay, we just changed the pointers in this case. We do not remove anything from the queue. That's interesting. So let's go ahead and get started to work with DQ. Accesses the queue. Okay. So for DQ, what we want to do is, let's go back here. Let's add it after this. Def DQ. Obviously, this is going to be changing the queue, so we need to pass it by reference as global. So if the function returns -1, that the queue is empty. So that means the head pointer has to be -1. So if the queue dot head pointer is equal to -1, return -1. That means there's no data in the queue. Else what we do is what we go ahead and do is the data is going to be the queue dot queue the queue dot head pointer. All right, and what we want to do is we want to go ahead and update the relevant pointer. So the queue dot head pointer, we want to increment head pointer at this point. What we want to do is head pointer plus equal to 1. Okay, there will be one more condition that if head pointer is equal to tail pointer. So what we want to do is we want to put an elif here. The queue dot head pointer is equal to the queue dot tail pointer. Then what we do is we also go ahead and return -1. And then we have the else statement over here. And then we return the data. All right, so that should be it. Head pointer is only incremented. We're not removing any data from the queue. We're just going to be going and taking the data out and returning the data. Okay, the main program also calls DQ twice. Each time it either outputs queue empty if there's no data on the queue, or outputs the return value. Okay, write main program that calls, and okay, a second time. Amend the main program. Okay, so the main program also calls DQ twice. Each time it either outputs queue empty if there's no data. Okay, so that means what we want to do is after doing this part, I think we have a 1 this time. Okay, and then it calls return data. So what we want to do is we want to go ahead and we're going to call this result once again, and this time we're going to be doing DQ. If DQ, oh sorry, not if result is equivalent to -1, print, what we want to do is queue empty. So we want to do go ahead and print queue empty. Else what we want to do is we want to output or output the return value. So print, what we want to do is we just want to print result. Okay, and then we want to go ahead and call print data. So print data will be called again apparently. So what we need to do is we need to print it here as well. All right, now let's go ahead and try 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So return, did I only call it once? Okay, I could use a small loop over here, but what's the big deal, right? So let's just do a shortcut. We really don't need that thing right now. Okay, we're gonna do 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So we got 10 and 9, and then we output this. Perfect. Looks good to me. All right, so that's concluding question number 2. Let's go ahead and start question 3 underscore n24 dot py. Okay, we're going to be, I think for question 3 we're going to be needing the text file. So let's start it. All right, so let's get started with question number 3. 2 has ended. We have tested the program. So question number 3, the text file highscoretable.txt stores the top 7 players' scores for a game. Okay, the data in the file is stored in the order of player ID, game level, and score. Each item in it. Okay, it's stored in the new line. Okay, great. So what we want to do is we first want to go ahead. The data about the players are scored in a 2D array with the strings with the identifier high score. Okay, all of the data type is a string. The first dimension of the array has 7 elements, 1 for each player. The second dimension has the of the array has 3 elements. Okay. 1 for player ID, 1 for the game level, and 1 for score. All the data in the array are stored as strings. Okay, great. So the first dimension of the array that's going to be the player name. Okay, great. So we got a game level for data in the array and the strings. Okay, cool. That's declared to the main local program, for example. Okay. So first we need to go ahead and do high scores. So high scores is going to be the array. So we first want to go ahead and do empty string, okay, for x in range of 7. Okay, I think, oh, this is an array, so we need to go ahead and do this times 3 for x in range 7 for y in range 7. So 7 by 7. I think this should be the correct method. Print high scores. Let's have a look. Okay. Okay, great. So I think that gives for high scores. Now what we want to do is each item is okay. Each item is stored on a new line, right? Okay, great. So the function read data reads the data from high scores table, okay, and stores the data in 2D array. The function returns the 2D array. The function uses exception handling when opening and reading from the file. Great. So the function is read data. Reads the data from, okay. So you have high scores over here. Okay. And returns the array. So what we want to go ahead and do is first do the try except statements. Okay, I've done my try except statement. Now let's go ahead and work on this. Try or I could also use the with statement, but I think I'm going to be sticking to the file statement now because we've got 3 sets of data. So what we're going to be doing is file. So we're going to be doing file file.open. The name is okay. Then we want to go ahead and store it in stores. Okay. So for the 7 data. So first we have the player ID, right? So what we have over here is player ID. Player ID is going to be file dot file dot readline. Okay. Next, we're going to be doing game level. That's going to be file dot split. Oh no. Oh, sorry. This is going to be stripped. Remove the data. Strip. And then again. Then we're going to be doing school is going to be file dot readline. We're going to be using the strip method. All right, and then we go ahead and put it in the array. But I think we need to put multiple loops in the array. All right, I think I'm recording had some issues over there. All right, anyways, we are back with the coding, right? So we're going to be going ahead and got the high school table, read data, and then we want to go ahead and store them in the array, right? So what we have to do is we have to go ahead and store all 3 of them in the array. So what we can do is we can go for high scores x, x o to be player ID. You could do another loop, but I'm not increasing the time complexity of the program. It's a little bit more efficient to kind of do, since we only have 3. High scores x dot 2. That's going to be a score. All right, that's how we put all the data in. What we want to do is in the for loop, that's what's done. What we want to do is we want to go ahead and return high scores, the array, and we also wanted to go ahead and do file dot close. Oops, sorry. There we go. So file dot close right there. Should be correct till now. Should work. Let's still kind of like give it a test run. The procedure output high scores takes the 2D array as parameter and outputs each player ID, level, and score in the order they are in the array. The output is in the form has reached. Okay, so we need to go ahead and put it in a sentence. Great. So what we want to do is we want to make another function, right? So we got def. Oops, sorry. Output high scores takes a 2D. So what we want to do is we want to go ahead and do high scores, right? And takes a 2D array experiment and output each. Okay, the player ID, level. Okay. So for x in range, what we want to do is let's do it to length, high scores. We want to go and output each of them. So we're going to print that's going to be giving me the player ID. Reached level. Then we need to find another. So we got to do is high scores x1 score of then we do is high scores x2 should work. Okay, The score, okay, first I want to go ahead and try out. I'm just gonna call it array, right? And then I want to go ahead and output high scores and give the array as an integer. I still seem to have an issue somewhere in some line. Okay, we have an issue here, but I don't get it where the issue is. But the Visual Studio line is pointing to something else right here. Somewhere over here. File, read line, file, read line. Something is wrong. Let's first run it. Invalid, did you forget to put a comma? Oh yes, I did forget to put the comma. I don't know, AI is just taking over. Okay, oh crap. Cannot access the logo file where not associated with a value. File.open. Oh, it's not, oh crap. This is just open. How could I make, okay. Did the code end or is it running with an infinite loop? Oh, oh crap. Okay, so what I want to do over here is we have a range of 7 over here. So what we could do is we could do a range of 7, or we could give a condition that in the case that since we only have around like 7 data over here, what we want to do is we don't want to output there we go. So it's going to be outputting all, it's going to output all the values right here. Okay, so but I think we're going to be running into an issue since we have we have range for 7. Okay, I don't get it. We had the range for 7, but why were we getting an issue with the high scores length? That's my issue over here. Why do we have an infinite loop? Is it because of the times 3 and for the y in range 7? Right? Like we have the y in range as well. Is it because of this? I guess so. So we're not outputting this. So that's why we're going ahead and doing just the 7. Because we've got the y in range, it's also outputting the other dimensions together. Right? It's actually considering the length of all the dimensions. So we're gonna go ahead and just do 7. Or I think we could do it for x, or we could check for issues regarding kind of being an empty string and not output the empty string. I think we need to do it for the next follow-up questions because I think it's a sorting algorithm. Yes, there it goes. So sort scores uses a bubble sort to sort the data described and return the sorted array. Write program code for sort. Okay, so since the question is not specifically mentioning me to make an efficient bubble sort algorithm, I don't think it's necessary to go ahead and use an efficient bubble sort version of the algorithm at least. Okay, so what we want to do is we kind of create sort arrays. I think that's the name. The score is not in order. The player scores first. Okay, the player scores are first sorted in the game level they reached. Okay. The player scores are first sorted by the game level they reach. For example, all players that have reached level 5 are higher in the score table than they have reached. Okay. The players that have reached the same level are then sorted in descending order of the score as example. Okay, so we need to kind of sort it in 2 ways at least. All right, so we kind of have to do a pass between kind of 2 parts. Okay, the function uses a bubble sort to sort the data described and returns the sorted array. Write program code for sort. Okay, so it makes it a little bit tricky in the way that we have to first sort for the game level and then followed by the scores. the scores each looks like will be different for each level at least. So we first need to sort via the game level area. So it's going to be position 1, 0, 1, and then 2. Okay, so we need to go ahead and sort it in that sense. It's going to be a little bit difficult, so let's see what can we do. All right, so first we're going to go ahead and do sort arrays. And then if you don't want to make it efficient, what I want to do is we want to go ahead and just do the nested loop. And it returns a sorted array. So I think we don't need to use a global or anything for that. So we're going to just leave it as is. So for x in range 7, then we could go ahead and do. So what we could do here is we could first go ahead and look for the sorting for the game level, and then we go ahead and sort it by score. I think that would be a reasonable way of approaching this problem. So we have to do, we've got 7, so what we have to do is we first need to find the length of the array, right? Let's see if it does the functions bubble sort as described. Sorted high score table. Use a bubble sort to describe the data. So what we want to do is first find the length of the array. So what we want to do is len array is going to be length of high scores. Then what we want to do is we want to take len array and we want to subtract 1 from it. And for y in range, what we want to do is we want to do len array minus x minus 1. So this is for that part of the problem. In Python, I don't think you need to do this -1, but let's first go ahead and write the code. And if we have, like kind of encounter an error, we're just going to remove this -1. But in Python, you actually don't need to do this technically. All right, so just keep that in mind. Because in Python, it's going to be going up to that point, and then it's not going to cross that point or kind of consider that point. So we don't need to go ahead and use this -1, but we will see. Let's go ahead and first do it. So first what I want to do is kind of sort it by high school score. So if high scores x, y, so what I want to do is we want to sort in descending order. So what we want to do is if this is less than high scores x, y plus 1, then what we want to do is we want to replace high scores x, comma y and high scores x, comma y plus 1 with high scores x, comma y plus 1 and high scores x, comma y. Since it's in descending order, so we're going to be putting the data of y plus 1 in y and the y plus 1 in the y plus 1 here, 2y. All right. And once we do this, what we want to then do is elif high scores x, comma y is equal to high scores x, comma y plus 1. Then we want to do is we want to go ahead and do the score thingy. So if now this y area, okay, wait. I think we can't directly do this. Like y is going to be representing the scores in this case. Crap. Okay, so it's going to be representing scores in this case. No, it's not going to represent the scores. Okay. So what can we do here? Okay, I think I kind of messed up the bubble sort algorithm over here. This should be y and this should be 1. This should be y plus 1. So what we want to do is we want to take y and we want to take y plus 1. That's the next element over here. And both of these should be just 1. And replace it with the values and in descending order, obviously. So we're going to do the y here, and this should be 1. Same goes for this, that if y1 and the y1 over here, then what we need to do is we want to compare y2 with y plus 1 and 2, right? If we go ahead and do that, what we can do is we can just copy this line and paste it in here and replace these with a 2. And just return high scores. All right, so next sort scores. Call read data, return the array, output before. Okay. So what we want to do is we want to go ahead and do read data. And read data will be unsorted array. And we take an unsorted array. Then we also need to go ahead and print before. And then what we want to go ahead and do is call up sort arrays. I think it would be like the question hasn't mentioned us anything to take parameters. I think I would call this high scores and take in unsorted array. Oops, sorry. Unsorted array as a parameter and call this sorted. Just call this sorted. Then print after, and also go ahead and output. Oh crap! Sorry, I ran it. Output high scores, and I want to go ahead and call it sorted. And obviously, we're going to be running into some error. Oh, okay. Let's have a look. And okay, voila, it is technically sorted. What if I go ahead and remove this one from here and just keep X? I want to test out with the Python methodology. Oh, okay, so the list index does go out of range in this case because Y is mentioned with X, and if it's like 0 to 9, let's say for example 0 to 6, plus 1 would make it 7. So we do need to go ahead and add a -1 in this case right here, and also to X. So that should be giving us fact. And there we go. All right, so the first part of the program is sorting the scores, I mean the game level, and this part is going to be the scores. So I'm just going to add a comment sorting by level. And over here, it's that if level is same, sort by scores. All right, so that ends today's video. Hope you enjoyed it, and I'll be catching up in the next video. And obviously, these codes will be available on my GitHub. I'll put the link in the description. Thanks for watching.